Question 4. Case 3. When the original condition and question involve inequality, we should practice getting rid of the fractions and making one side equal 0. Example 3. If a is greater than 0 and b is greater than 0, is a over b greater than b over a? Condition 1. A is greater than b. Condition 2. A plus b equals 5. Solution. Now we will solve this DS question using the variable approach. Let's apply the 3 steps suggested previously. The first step. Modify the original condition and the question to suit the type of information given in the conditions. Case 3. When the original condition and question involve inequality, we should practice getting rid of the fractions and making one side equals 0. We have to find out whether a over b is greater than b over a, if a is greater than 0 and b is greater than 0. We should get rid of the fractions wherever possible. Here we know both a and b are positive, so we can cross-multiply without any effect on the inequality sign. Then we get whether a over b is greater than b over a, or whether a squared is greater than b squared. This can be further written as whether a squared minus b squared is greater than 0. This can be factored using the difference of squares, which gives us whether a minus b times a plus b is greater than 0. As a and b are positive, a plus b will always be positive. So our question can be modified as, is a minus b greater than 0? Or is a greater than b? By simply modifying the original condition and question, we have made this question an easy one. Let's look at condition 1 then, which tells us what we are looking for, that a is greater than b. We get yes. The answer is unique, so the condition is sufficient by CMT1, which means that the answer must be in terms of a unique yes or no. The same logic applies here too. The modification, the first step of the variable approach, is the most important. Condition 2 does not give us any unique value from a plus b equals 5. For example, if a equals 3 and b equals 2, a equals 3, which is greater than b equals 2. We get yes. But if a equals 2 and b equals 3, a equals 2, which is less than b equals 3, we get no. The answer is not unique. So, the condition is not sufficient by CMT1, which means that you get both yes and no as the answer. It is not sufficient. Condition 1 alone is sufficient. So, A is the correct answer. As shown above, in case 3, the original condition and question involve inequality, and we should get rid of any fractions and make one side equal 0. The simple idea of making one side equal 0 will allow you to solve questions that you previously found very difficult. Answer: A.